Today, the new-collar workforce is replacing the old blue-collar one. But how and in what ways? And what exactly is a new-collar worker? Well, just as the automobile, electricity, and television once disrupted the way business was done, today we face our own set of disruptive technologies, including everything from robotics, digital design, and 3D printing to cybersecurity, artificial intelligence, and more. These new-collar jobs are born from these technologies. In fact, contrary to popular myth, these technologies will not be robbing people of their jobs, but rather transforming them, and additionally doubling workforce demand, creating an entirely new-collar workforce, and a collaborative relationship between human and machine, where robots do the heavy lifting and humans do the more innovative and creative work. In addition, many of these jobs do not always require a traditional degree, explains Ginny Rometty, former IBM CEO, who actually coined the term new collar. What they do require is the right mix of in-demand skill sets. And according to author of People of the New Collar Workforce and co-founder of the New Collar Network, Sarah Boisvert, one of the most important of those skill sets is problem solving. 95% of 200 employers she interviewed said they were seeking workers with above all problem-solving skills. Other needed skills are being taught and utilized in Fab Labs around the world. Skills that include laser cutting and marking, 3D printing, CNC machining, vinyl cutting, microelectronics, for wearables especially, robotics, and AR and VR. These Industry 4.0 demands now require a more efficient and effective educational model to fill this skills gap in the workforce. Enter the digital badge, a modern version of what could be called today's high-tech faux-tech. Short-term, affordable, skill-specific training in these technologies that can be utilized in everything from the aerospace and automotive industry to cosmetics, filmmaking, dentistry, bioengineering, microfluidics, and more, including all things artistic. Nearly every industry is being impacted by what is being called this fourth industrial revolution. And these digital badges are the new professional currency that provides the evidence needed for employees and employers to verify these skills. Currency is a measure of digital badge program value. A group of nonprofits, Fab Labs, makerspaces, businesses, colleges, and K-12 schools saw the enormous workforce development need for both 21st century employees and employers, and as a result, started the nonprofit, the North American Digital Fabrication Alliance, to offer a new way of providing this in-demand workforce training. They recently obtained 6 new members and are a growing organization. And they utilize what is called project-based learning, where students create a project portfolio that acts as the supporting evidence to show how the badge earner identifies and solves a problem using new-collar skills. In addition, they adhere to the Open Badge International Standards and have made these micro-certification programs available online, which levels the playing field, offering the same opportunity of career advancement to all, regardless of race, gender, economic status, or location. A person in a remote location like Roswell, New Mexico, now has the same opportunity and credibility as someone from Boston, Massachusetts. These badges offer a prime avenue for economic growth, especially during times where we have faced one of the greatest economic downturns in history. These micro-certifications stand as a beacon of light to transform not only our economy, but our world in a way never seen before. New Collar Network co-founder Sarah Boisvert talks about the important role these jobs will play in the larger context of human history.
I grew up in a traditional middle-class family. We never wanted for anything. I went to private school. I had piano lessons. My dad would pile all the kids in the car. On the 4th of July week, all the factories closed. And all the kids and their parents would go on outings. You'd go to the shore, you'd go to visit historical places like DC, and it was a really idyllic lifestyle. It was a wonderful way to grow up, and that has really changed as we have seen our jobs go away. All of those things that we need and want, the new Tesla, the new electric car, those smartphones, or being able to get to Mars to colonize outer space, all require people to make these new technologies. We entered a digital age for smart manufacturing, and that has really changed what manufacturing looks like. These new technologies have transformed our blue-collar jobs, and they've become digital. A CNC machine now needs CAD design. We're now working with robots. We're working with lots of different tools and technologies that didn't exist in its previous incarnation. These are jobs that incorporate new technologies that come out of science fiction and are the things that kids today see all the time in video games and movies coming into the real world. But with that, there's become an enormous skills gap. So these new technologies have changed the way that we work with traditional tools. And many different groups have done research that shows we're facing enormous gaps in the number of skilled people. Just having a warm body isn't enough. We actually do need to have people who have the kinds of skills to operate these new technologies. And it's particularly severe in manufacturing, where we're seeing exponential rates of change on the factory floor. We're also seeing that jobs are becoming automated. This is one of my favorite products. It's produced by a company called Local Motors, and Ollie, which is the name of this people mover, is a 3D printed electric autonomous vehicle. So now we're incorporating in this one device 3 major changes in how we think about a product, how we think about moving people around, how we think of transportation. I was interested in looking at what are those skills that we need brought on by these new technologies, these disruptive technologies. And to do that, I interviewed about 200 manufacturers that ranged in size from Fortune 10s, so companies like GE, Apple, General Motors, Ford, Boeing, Boston Scientific, all the way down to startups and companies that are working on new technologies for the future. And I was interested in knowing more about the needs that they had for workers in the operator arena and technicians, because that's where the real skills gap. We've been encouraging people for a long time to become engineers, and we've lost people who have the skills that we need for operating machines and for servicing them. I shouldn't have been surprised because I owned a factory, but the number one skill that people said they needed was problem solving. 95% of the 200 companies listed problem solving as their ultimate problem. And I really think it's because the technologies are so new and are changing so rapidly that a new worker on the factory floor can't go to Joe, who's been there 20 years, and say, how do I fix this machine? What am I going to do? It's not running. And I think that that is driving a lot of the need for problem solving. And also a lot of the companies that are developing these new technologies are startups and don't have the customer service in place like a big established industry would. And so problem solving has really come to the forefront of a job skill that's needed in today's workplace. The manufacturers also talked about hands-on experience. And that's not very surprising. When I was a kid, guys would get an old car, fix it up, and they had lots of experience with taking things apart, and today that doesn't happen. And one factory told me that they go to the farms. They're in Louisville, Kentucky, so there's lots of farms around them, and they're able to go and find people who have experience with manufacturing things on the spot and making things happen. They also, of course, mentioned digital and computer skills, but that wasn't until in third place. The digital skills they mentioned the most was CAD design, and CAD design has now become the key to manufacturing. We have very few tools that do not work digitally, and CAD has really taken over how we think about advanced manufacturing. Whether it's laser machining, CNC machining, or 3D printing, CAD is the basis of all of those processes. They also mentioned predictive analytics, so we have big data, and suddenly what do we do with all that data, and how do we analyze that? And so experience with these new software programs that help us to take all of the information coming from the sensors on the production lines is a key skill if someone wants to work in manufacturing. A big topic is, of course, 3D printing. At the Rapid Show a few years ago, HP introduced a production 3D printer. And all around me, a meeting of about 10,000 people, I repeatedly heard people say, I'd love to buy that 3D printer from HP, but I haven't got anybody to run it. And one of the real problems that I see, I get invited to visit a lot of factories, and invariably when they hear I've worked in 3D printing, they will ask me to come look at their 3D printer. It's not running well, they're having issues with it, and the big question is, can you recommend a better 3D printer? And in fact, there probably isn't a better 3D printer. They've got some poor IT guy who happened to build a home version in his basement, so he must be the expert, and he has to run the 3D printer out of his back pocket in his spare time. And I visited a wonderful factory in Attleboro, Massachusetts, and they make custom jewelry for like the Super Bowl rings and the sports rings, and as well as corporate things that have to be designed individually for each job. And this poor IT guy is having to run the 3D printer and figure out how to make it work while he's still got this heavy workload. And what I suggested to them was that they go to the local college, find an intern, and call me in 3 months. And sure enough, they called me in 3 months and said, you were right. You know, we just needed somebody who could spend the time. The kid that they hired, it was actually a young woman, engineer, was so thrilled because she got to work with this $50,000 3D printer and to do some really fun work. And but what I hear over and over is, I have problems with my printer, and the real need is to have somebody who understands CAD and also understands how to run the machine and troubleshoot it. Which comes to my favorite slide of the need for 3D printing service techs. I can show this picture because the cube, which actually is what I use to make my cube earrings, is no longer in production by 3D Systems. And so this is not anything about their machine. They decided to go more into the production and industrial world and no longer make the cube. The cube, though, was one of my favorite printers. And one day my intern came in. We were making 3D printed parts for a prosthetic hand, and he came in and the other half of it was spaghetti. So he got a few parts out of it. But this is not unusual. 3D printing is better than it was. It's starting to come more into the forefront, but without someone to really take care of it, without someone to really monitor it and to unclog it when it's clogged. Extrusion clogs all the time, no matter what kind of work you're doing. Even extrusion for PVC pipe clogs. And so it's really important to have somebody who knows how to repair these machines. I'm also hearing from the manufacturers that they're having a hard time finding people to hire as service techs. There was a company in Albuquerque that had a job opening for 6 months that they couldn't fill. They couldn't find anybody who could they could hire with the experience that they needed to go into the field and actually make the machines work. But these disruptive technologies are changing much more than manufacturing. They're changing all kinds of industries. One of the interesting examples is from finance. There are now robotic programs that do a lot of the automation in these huge numbers of transactions, and it allows their people to be able to do higher level work. So there is a company that I believe is in the UK, and they use these robots to monitor. It's a software robot. It's not a person robot. It doesn't look like a person. It's a very interesting concept. It runs 500,000 transactions a day, which for humans to do would take a huge number of people. And you think, oh, the staff is going to be really upset because they're losing their jobs. But the staff is thrilled because it allows them to do much more interesting work that is a whole lot more fun. And they like it so much that they've named their robot software, I think her name is Cindy, and they invite her to the Christmas party. So it's, I think there's lots of change happening in medicine. We know of a lot of robotic procedures that are happening. It's happening really all across all of our industries, and I think it's leading to a lot of change in how we have to think about technology. One of the big areas where people are thinking they're going to lose their job, as I said, is in robotics. And at least at this point in time, my feeling is that we still need humans to design, program, and yes, fix the robots. If you've seen any of the YouTube videos of robots falling over or doing, crazy things, we still need some human to be part of that. I was at a trade show in Boston, and there was a huge booth that had lots of robots in it, and they were running around, and it was really entertaining. And I noticed this kid in the corner, and I went up to him and said, so what's your job? Because he was clearly not a salesperson. And he said, oh, well, I keep the robots running. and what a fun job. I mean, for a young person who grew up with technology and saw it in the movies or has seen it in video games, how fun to be able to work with them. And I always like to say that despite advances in technology, machines do not innovate. It is humans who innovate, and we use those tools in order to innovate better solutions to our lives in the world. I talked a little bit earlier about big data and predictive analytics. A lot of the again, the collaboration there comes between machines and man. So while these sensors pick up the information and the data, and the software can analyze it and give you some indicators, it's still the human who has to take that information and figure out what to do with it. So the machine may say, we're due for maintenance on this date. But if it turns out you're selling the company and you have visitors coming and you really want the machines to look good, you're going to move that up. It still takes that integration of lots of different kinds of information in order to come up with the correct decision. So when I got done the research, I really realized that it's people that are the key to digital transformation. It's not the machines, it's not the technology, it's the people that make it work. And it's really the people who are at the center of all of what we do with technology. I also realized that all of the things that the manufacturers told me they needed are the kinds of things that we do in Fab Labs. So Fab Labs are digital fabrication laboratories that are based at MIT at the Center for Bits and Atoms. And we have all those tools, but we really work in very specific ways in problem solving, and we work with our hands, and we're working with 3D printers and all of these exciting technologies, but in very specific learning modalities. And it seemed really clear to me that a new kind of training is needed. I had thought when I did the research that we were going to write a 2-year curriculum for an associate's degree, and I got done and I realized the employers want skill-specific training. They want employees yesterday. The need is immediate and desperate. I've had people in many parts of the country say, just send us warm bodies. And they want problem-solving skills. They want a very different kind of student than we have traditionally trained in education. And for the students, the world has changed. This picture is a high school student who is the son of the current CEO of Potomac Photonics, the company that I sold. And when he was a high school student, he was working with an Israeli biotech company that is a microfluidic device with embedded sensors. And you know, kids didn't used to work on this kinds of stuff when I was young. But the times have changed, and people are now having so much access to tools, to software, to the videos that are on the YouTube channels, and the kids want careers and not jobs. They want to make impact on the world, and they want something that will not leave them a lot of debt, and they need for it to be time effective. It's particularly interesting because at my labs in New Mexico, we are a state that doesn't have a strong history of education, and a lot of the students, particularly for these kinds of jobs as operators and technicians, don't really have a traditional trajectory. They don't get done high school and go right to college. A lot of the students at the community college where my lab is located have families. They have children, they have a family to support. They often are working with their parents and helping their parents. And so it's a very important thing to have education be accessible to everyone and to people who didn't traditionally think that college was an option. And so as I looked at all of these factors, I realized that we really needed to think about a new way of educating, and digital badges to me seemed like the best way to verify skills, not just for the employers, but also for the students. There's data inside every badge, and so digital badges were developed originally by IBM and Mozilla. Mozilla in recent years has formed an open badge program that is open source. There is an international body that verifies the standards, and it allows a documentation of a skill that is verifiable. And ostensibly, although we don't know in this day and age if something is always secure, but ostensibly is secure. But what's most interesting to me is that there's this back end. And so not only do you have a piece of paper that you come in with that says, I've got a certificate in CNC machining, say, we can put a project documentation on the back end. And so we can, because we're project-based learning, we can have every student document what their problem was, how they identified the problem, which is half the battle in any field, and then how did they solve that problem. And so they can have photos and videos and technical specifications of how they actually came to their conclusion. And for an employer, it's really powerful because I can look at it and say, oh, they got stuck there, but what did they do? Did they go around it? Did they plow through it? Did they come up with a really creative way of thinking about the idea that they had to solve the problem and create something new and different? Or did they get really stuck and not able to come up with a solution? So I think for the employers, it's an incredibly powerful tool to make that connection on a much deeper level. Fab Lab Hub has funding from America Makes, who you saw earlier in Youngstown, Ohio. That was through the Department of Defense to create digital badges for additive manufacturing, because that's our start, that's the most immediate need. But what I'm really hoping is that we can create a new color network where the employers and the people trained in these kinds of technologies can be able to find each other. So if an employer is looking for somebody who has CAD design skills, they can go on to the platform and find somebody and see what badges they have, which particular softwares they have. Do they have design for 3D printing? Do they have 2D design? And I think it will be a very powerful way for us not only to train people, but to help them with that transition to the workplace. And so, as I look at this project, and as a manufacturer, it's an important problem. We really need workers. We need to be able to have a good economy. But going back to thinking about my father and his first job, He ended up becoming an entrepreneur, which is where I probably get this focus. But his first job went away. And when we think about the nice lifestyle that we had, when we think about how our people were able to support their families, that people were able to do interesting work and be able to really have a wonderful sense of community and that middle class that was so strong in the US. What I really hope is that the new collar workforce and all of the technologies working together with people are going to be able to spur economic success, not just for the manufacturers and the people who need workers, but for our communities, in order to build strong communities where people can take care of their families, where people can feel empowered and a part of the greater universe. Thank you so much. And if you would like more information, all of the research is covered in depth in my book, The New Collar Workforce, which was published by Photonics Media Press, and you can find it on their website. Thank you again.
We're kind of a complete do-it-yourself, get it done all in one system, one set. I can go from a customer giving me a drawing to making any fixtures I need to make their part, to working with their drawings, to programming the laser. I can do it all. Started here pretty much right out of high school, got all my education right here, so it's been a fun ride. So I was actually brought in by a family member. My aunt is actually the vice president, one of the vice presidents. So she got me the job years ago when I was a kid trying to figure out what I wanted to do with my life. Here it is 14 years later, and now, like I said, I'm setting up my own systems and running my own jobs. It's been a long road, and it's been a fun road, and I've learned an insane amount because it takes a lot to be able to run a laser and do everything involved in it. One of the coolest things that I did was when we got into 3D printing technology. That was awesome because we got the new system. I actually went and got certified on the system. I got to play with the system, from loading the part that is just a picture, because that's kind of how the 3D printers work. You put a picture in and you get a finished product. So, watching that whole process, learning how the system works, learning how to clean the parts and get a finished product, stuff like that. And then when I was making fixtures and being able to do everything we needed for the jobs, we have the full machine shop in the back. So getting on the mills and getting on the lathes and things like that, it's really interesting. And that's really fun. I'm very hands-on, so I like when I can go and work with, heavy machinery or tools and do some of those kinds of things, as well as working with the lasers. So there's many different aspects, and it's all very interesting to me. I can look back at school when I was a kid or growing up to being a teenager to, a couple of semesters of community college I did on basic coursework. And then I can also fast forward not only through the workforce, but also I've done a few semesters more recently on more focus towards the work that we do here. And, I was no straight A student back when I was a kid. When I went and did the more futuristic semesters and the stuff that I've done now, working with the stuff that we're doing now, straight A's, no problem. I mean, not only are we on the cutting edge of technology and everything on that standpoint, but I mean, you look at it, you have great days, and no matter where you work, you're going to have your bad days. But where can you go to work and have a bad day and say, I got to play with lasers all day?
Hi, my name is Maite Cardenas, and I'm a jewelry designer who works with 3D. I started 3D designer for quite a few reasons, and one of the reasons it was that there was items that I needed to create that wasn't easy to create by hand, or will take a lot of time, or when I was doing specific jewelry for a person and they added their name or different other things that were more difficult to do by hand than doing it actually in 3D. That's when I decided that I needed to learn how to use it. If the tool was there, why not to use it? When I was trying to learn how to design. The first thing I did, I went and talked to a company to buy a program, the program that I thought was the best. And I talked to the company and asked them if they have a class where they could teach me how to use the program. They say, yes, they do have it. So I told them, I want to take a class, and if I like the program, if I think that is what I need, then I will buy the program. So I did buy the program, and I really enjoyed it. It took me a long time to really, I cannot say master it, but to be able to work with it and able to create what I want and what I like to create. Yes, it took me quite a time to learn it, but it's about practicing. When I was hand making the jewelry, just hand making, so I took classes to how to make jewelry, but when I tried to go to 3D design, I had no school. I only went to middle school, so I needed to just always focusing on what my interest was, that was jewelry. So when I decided to learn 3D design, it got difficult point, because sometimes when you go to school, they have so many requirements. But then I insist until I found the way, and it was when I bought the program. But then I went to the community college, and then that's when I found Fab Lab, or Sarah, who was having some classes on it, and which make it a lot easier. When I started working on 3D and I really love it, I got passionate to it and decided I wanted to buy a 3D printer. And I thought it was easy. I just went and researched some of them. Of course, money was a big thing, right? So I tried to keep it as economical as possible. So I got the 3D printer. I had to learn how to use it, and I had so much trouble trying to use it. There is so many little things that if they're wrong, your pieces are not going to be right. But then I was still thinking that the problem was my design. I never thought that the problem was the resolution of the 3D printer. And that's when the help of Sarah, with her special 3D printer, really came out and saved me. The Form 2 3D printer is actually the one that has the best pieces. It's when I design, of course, the sketch and then sit down at the computer and take my time. And when I'm really happy with the piece, I can actually send it to Fab Lab, and they will print it out for me, which saves me time, where I can either keep designing, or time for selling, or time for casting, or whatever else I have to do. And it really increases the production of my pieces, and it helps me with time and saving actually the time to do other stuff, selling or promoting or whatever I have to do. But when I was dealing with my own 3D printer and all the problems that I was having to 3D print, then it was taking more time, and it was being successful. But then now that I can actually leave the work to Fab Lab, it really gets it much better, faster. The pieces are very clean, well detailed, and when I go to the casting process, I don't have as much trouble as I used to have. Now that I found the batches, the Fab Lab of the classes that we're having at the community college, then this helps me to create much more complicated pieces. It helps me to concentrate on things that are going to be easier to build and more beautiful, more complicated, and because I have the time, so because they are printing my pieces now, so I have the time to concentrate in doing a lot of more things. At the same time, I decided that I want to keep taking more classes, because I need to learn more about, not just about 3D design, but about 3D printing and how it's advancing, how the technology is moving us in a way that is getting our lives easier, not just easier, but more comfortable and more beautiful.
Hello, my name is JC Ramirez. I am a student at the Santa Fe Community College, and I'm doing a degree in graphic design. How I got interested in the Fab Lab here at the community college is because I did an internship with them. I found out about them through my 3D design teacher who told me about the internship opportunity, and I decided to, try it out and see how I liked it. And once I started, I just couldn't get enough of it. I really enjoyed creating things in 3D and then having them printed out. I just thought that was like a wonderful opportunity for me. I just thought that was a way I could, keep increasing or keep working on my skills for design. So my background is in obviously design, 3D animation, graphic design, website design, a lot of media art stuff. That's what my degree is in. So I kind of wanted to just test the waters with 3D printing, see if that was something that I could, learn more about. Added to my skill set. When I was doing my internship with the Fab Lab, I kind of was taking on more different aspects of 3D printing, like servicing, like the behind the scenes, like taking the machines apart and seeing how they work too. That's also kind of what I got interested in doing this for, is being like a technician for this cool stuff, this cool machines that help with the art process. Here at the Fab Lab, I was lucky enough to use my skills that I've learned before, like my video skills, to create the workforce training videos that we use to train the students, to train anyone trying to learn how to use their 3D printers. My favorite thing about working at the Fab Lab is that I get to use all my skills that I've learned from before, my graphic skills, my video skills, my design skills. It's just a good place to, bring all those together to create something new, either helping somebody else, with their projects, or, having my projects done here. Originally, I thought the Fab Lab was going to be more technical stuff, so more engineering stuff. Like I thought it'd be useful to have a degree in like engineering, but actually I found out just having my media arts degree was kind of like bringing the creativity and the technology together. But for me, I was kind of interested in technology and more of the art stuff, but I still wanted to see how it was for me. I was able to learn the engineering stuff behind how the machines work and to kind of, help with anything they needed. So I think that was very, attractive for me to, bring those two aspects of working at the Fab Lab together. Working with the engineering people here and working with like my creativity and like bringing that into here was like what made the difference for me. So my background is in, again, graphic design and working with programs like Illustrator, Photoshop, and some 3D modeling stuff. So that made it a lot easier for me to kind of get into the 3D printing world. I kind of have some familiarity with how some programs work with 3D models. That kind of made it easier for me to transition into working with the slicers that we use, the slicing softwares that we use for the machines. It was a very natural transition for me to, start using my skills for what we do here. Having a background in media arts definitely helped me, enjoy this job. I very much enjoyed working here. I very much enjoyed using my creativity, my set of skills, and bringing those into this type of field, And I would definitely recommend anyone who has a media arts background to, at least learn a little bit more about 3D printing and the possibilities you have to, at least expand your art. But it's not also just for like the engineering people that use digital manufacturing for their project, but it's also for like the creatives who want to explore new things, explore new mediums for their art, to bring their creativity into the world of engineering and design.
My name is Judy, and I work as a program assistant for the 3D printing store in Centennial, Colorado. I was still working in healthcare as a hand therapist, and I had been seeing a lot of fun things going by in social media and various places about how cool 3D printing was, and I really wanted to get involved in it. And then I had a patient with a special need come through, and I thought this might be our opportunity. And so I looked in Google for places in Denver, Colorado that were doing 3D printing, and lo and behold, a former patient was running a 3D printing shop in Centennial, Colorado. So I said, hey, can you guys make this? They made it. I fell in love, and they couldn't get rid of me after that. I begged them to come let me hang around the shop and learn some more. And so they said, oh yeah, we call people like you interns. And so it was me and all the other 12-year-olds in town hanging around at the 3D printing store. And so I like to call myself the oldest living intern at the 3D printing store. My master's degree was in occupational therapy, and I worked for 25 years in healthcare. But I was one of those women who, when you're of my youth, when you grow up in a small to medium-sized town, you're either going to go into healthcare or you're going to be a teacher. And I really probably should have been in engineering or in the sciences. But that, I just didn't grow up in a family that was capable of recognizing that. And so I did, healthcare was good to me. I did my time. But when I got a chance to make a break and get a chance to try something new, I just fell in love with it and decided to dig my heels in and make a change. I do a variety of things. It's nice sometimes I'm able to kind of give consult when people come in with healthcare products, and I can help design them. I'm, learning to be a designer. So they give me some of the more simple design projects, which is wonderful. I love to do that. I've learned to use all the printers, so I take items off the printers after they're completed, finishing work, sanding and finishing, and kind of just whatever they need help with around the shop, kind of a gap filler. I'm learning SolidWorks right now, and I love it, it's the most wonderful thing ever in the world. I survived AutoCAD 3D, which the students at ACC call AutoCAD 2.5D. I had a couple semesters of AutoCAD, and I'll start working more with Bentley MicroStation in a couple of weeks. So just hanging on to SolidWorks as long as my student license will hold out. It's just so amazing. That the amazing thing about 3D printing is that it's so empowering to innovators. People come in here and they can't help themselves. They're makers, they're creators, they are people who have to try to see if they can do it better. And it just empowers them. They walk in the door with these things that exist no place but in their head, and they walk out with the device in their hands. It's just the most empowering thing. The designers are awesome. They're my tutors for my SolidWorks class. The guys are always available to help me figure out how to design something so that it will print. They oftentimes will set me up with workshops because they have offers for free training seminars, and so they'll always forward those to me and let me get a chance to get in on those. And so there's just always a chance to learn. Recently I had to write a paper on a manufacturing technique for a class, and so I got to go up to Elementum and see where they're doing direct metal laser sintering, and that was amazing. So it's just been a really great place to get a lot of opportunity. I would love to be able to take my healthcare background, because I was always the therapist that anytime a rep brought something in, I would take it apart and tell them how they should have built it. And so now I'm building some of my own things. But I don't feel ready to do that. I don't feel fast enough and strong enough to do that for somebody else yet. So I've taken a job as a drafter after the end of the semester, and I'll be drafting for a little bit as I continue to develop some of my products and grow my SolidWorks skills. Hopefully within a couple years, I'll be able to work as a designer for somebody. That would be the end game goal.
Hi there, my name is Katie Wolf, and I'm a 3D scanning specialist at Direct Dimensions. We are a company that focuses on creating digital models of real-life objects through 3D scanning and processing. These models can be highly technical and precise for applications in engineering or manufacturing, or they can be on the more artistic side for movies or for sculptures. Because of the focus on all things 3D, a typical day for me in the office can vary greatly. Sometimes I'm out on the field assisting coworkers in capturing the architecture of a building, and other days I'm just simply at my desk cleaning up 3D scans. Although I'm one of the newest employees here at the company, I really enjoy working with all of the people in my group, and I especially appreciate that we come from all sorts of different backgrounds. Some of us are RIT graduates and engineers, and others came to the company without a degree and owned businesses prior to working here. You could also say that I came here unconventionally because my background is actually in art. If you had told me 5 years ago that I would be a 3D scanner, I would have not believed you at all. I decided to study art at the Maryland Institute College of Art here in Baltimore, and my initial aims were to be an art teacher or even a museum worker. But 2 years into my degree program, I was introduced to 3D scanning and 3D printing, and after that I was hooked. I wanted to learn everything about 3D printing and 3D scanning, and I started to learn the software that helps you create digital models by taking pictures. And because I had been working in a museum, I decided to start making digital models of objects that were on display at the museum to help with the educational side. So I ended up doing that, and then after I graduated, I was lucky enough for DDI to hire me, and I'm proud to say that I'm still doing the same thing today, helping museums make their collections digital, and I'm also working on a whole host of other things.
The New Color Network Additive Manufacturing Apprenticeship covers FDM 3D printing, since that is the fundamentals of additive manufacturing. We also have programs that cover stereolithography and also production. Recently, through a generous grant from the Northern New Mexico Economic Development Corporation, we were able to get the beautiful Nexa 3D printer that is sitting behind me, that is very high speed and will allow us to get into high volume manufacturing. When we first started looking at how to fabricate the New Color workforce, it was pretty clear that the digital badges we had created were an optimal way to train people for these new kinds of jobs. But there is also the component that we needed for hands-on learning on the job. And I looked back to a very tried and true process, apprenticeships. Apprenticeships have been around since the Middle Ages, when they were known through the guilds, and are still really popular in Europe. In the United States, it's the trades that had really embraced apprenticeships. And what we need today are 21st century apprenticeships that are upgraded for the 21st century new collar jobs. We need apprenticeships for additive manufacturing, 3D printing, laser cutting, AI, and all of the other kinds of disruptive technologies that are now ubiquitous across industries. With the help of Jennifer Odo, who is now the head of workforce programs at Youngstown State University in Youngstown, Ohio, we were able to get a U.S. Department of Labor registered apprenticeship for additive manufacturing technicians. We are just thrilled to work with Youngstown State and really embrace the apprenticeship model with all kinds of new 21st century education alternatives. Our training provider is through the New Color Workforce Digital Badge Program, as well as IBM IT badges and the Society of Manufacturing Engineers, SMEs, additive manufacturing certificates. With the help of America Makes and the Urban Institute's framework, our program was readily approved, and we have apprentices right now working in Fab Lab Hub's facility in Santa Fe, New Mexico. tell you a lot about apprenticeships. And to do that, I thought it'd be really fun to talk to our real live apprentices who started with Fab Lab Hub this past year in the U.S. Department of Labor registered apprenticeship for 3D printing technicians. This is Alec, and I'm going to let Alec tell you a little bit about his background and how he found us.
Before working here, I was learning a lot on my own, through a lot of different resources, trying to patch things together, and then, working a lot of different jobs to sort of support that. And it's just an amazing opportunity to be able to learn additive manufacturing, 3D design, even laser cutting. So just to have it all in one place and be learning every day, every week, something new, it's pretty cool.
So tell us what your job was when you found us.
Yeah, I was in the midst of trying to start 3D printing sunglass company. And what I was saying, I was patching everything together, working for my friend's company, working at a restaurant part-time, and just spread really thin. So it's like just a great opportunity to just consolidate everything and be learning in a much more structured way too. Yeah.
And this was during the pandemic.
Yes, yeah, so throw that in there and a couple other things too, so.
Yeah. And I think that's one of the things that we saw was we had 100 applications, and a lot of the people who applied for the two positions were displaced COVID workers, and it was really gratifying for us to have people come in to learn a skill. We have done some research since, and there's about 1,000 jobs within probably a 30-40 mile radius of Santa Fe, New Mexico, where a technician is required that has 3D printing skills. And so I think the opportunity is really great. And so tell us about the badges.
Right, so that was the first step to working here, was working through each of the badges and kind of the whole progression. And it's such a great way after going to college for 4 years and high school, junior high, elementary school before that, to just have this consolidated education and to see how much you could really learn in a short amount of time is pretty amazing.
Well, it has a lot of focus.
Yeah, exactly, which I think a lot of other things don't. So
yeah, and I think the fun part of the badges is the projects.
Right.
So do you want to describe one of your projects?
Yeah, it was for a different friend trying to start has a ravioli delivery company, and they have these ravioli trays that he's saying are always too small, and he wanted to put a logo or something fun on the raviolis. So kind of classic moment of, you could 3D print this. So it was perfect timing, taking one of the classes, designed a modular ravioli tray for my friend, and it was right size project for the class, and it all worked out. And even since I've been learning a lot of that on my own, there's just so much in the badge that I wouldn't have known different processes without the help of an instructor for this specific project. So it's pretty fun.
I think the projects are fun.
Yeah, totally. Yeah.
And we're so excited to have you join us.
Cool. Yeah.
Thanks.
It's been great.
So why don't you tell us about this project that you worked on for the lab?
Yeah, so we have, as you can see, just so many different 3D printing artifacts, trinkets, things we've designed. Be an hour-long video to go through all of it, but wanted to make some sort of shelf displaying them, and came to the idea to laser cut these panels and then to 3D print the hinges, and then it started coming off the wall a little bit, so it has these little inlets for the tacks, and since then I've just been like falling in love with hexagons, and kind of they're starting to pop up everywhere else too. So
It's a great solution, and it really is aesthetically beautiful.
Yeah.
Compared to the
Yeah.
mess we had before.
Yeah, the bees knew what they were doing.
Yeah. Yes.
They started that.
The apprenticeship program here at Fab Lab really draws from different parts of our state, and Jed, who is going to talk with us today, lives in Los Alamos and grew up in a rural area. And I really appreciated when Jed applied for this job that he had experience with fixing all manner of things on his dad's farm. And Jed can fix just about anything. Jed, do you want to talk a little bit about what you were doing when you found us?
Well, I lost my job to the pandemic. I was working at a restaurant, and my girlfriend was taking classes, and she emailed me about some 3D printing class and that she didn't want to take, so I took it. And then we were working on it's called a Brolim knob, but another name is a suicide ball for a tractor. And it's like postal workers have them on their vehicles for, like one-handed operation of the steering wheel. And that was my project. I talked to the instructor about, hey, do you know how I can get paid to do this? And next thing you know, I'm working at the Fab Lab.
And that class I had offered to Rick Bailey, who is the president of Northern New Mexico College.
Oh, he was there before I
graduated. Or after. He's there now.
After, yeah, sorry.
Yeah, he's there now. And it was just, serendipity that I sent an email to Rick, who then passed it on to instructors and who spread the word.
To a student who spread the word to me.
Yeah.
So.
Yeah, that was good. That was good. And I really like that we were able to bring people in who were displaced by the pandemic, because I really believe that the economy needs to be diversified, that we can't just rely upon tourism, that we need high tech and we need well-paying, engaging jobs. And every time I come in, the first thing you always say is,
what do I say?
how much fun it is.
Oh, yeah. Yeah, it is a lot of fun.
So let's do it again. So when I come in, the thing Jed always says is,
how much fun it is.
and I don't pay him to say that.
No, she doesn't.
You really are having fun.
Yeah. It's a lot of fun. I'm always doing something, and it always changes, so it's hard to get bored.
We had a really interesting project of assembling the beast, and that was, I think, one of your more challenging projects.
Yeah, that was a nightmare, to say the least. Well, it wasn't that bad most of the time, but yeah, being able to work with my hands is really cool. But also, I'm kind of not working with my hands. Like, I'm not out in the feet, working on cars or anything, tearing up my hands. But it's cool to be able to make something. It's kind of a dream job. I love it.
That's great. So I think that in the Beast project, it was really challenging, and it forced you to really use a lot of problem solving.
Yeah, I had to get creative. We wound up having to fabricate parts, order parts, rewrite the firmware. I did some soldering. It was kind of all led up to that moment. Like, all the skills build on each other. It's that Iron Man stuff.
It was a complete redesign. We thought we were going to assemble a machine, and it was a redesign.
It just didn't work from the get-go.
Yeah.
The poignant moment was when I finally got the Z-axis to move, and it was lifting up and up and up, and then it just started. It was like just a fraction from touching the Z probe. It would like almost work, and that's when I threw in the towel.
And we're doing, or actually Jed is doing a complete rebuilding of a variation on it.
Yeah, we're going with this open source design that is it's got some impressive numbers. It's something like the printhead can move at something like 2 Gs of acceleration. It's nuts. But we've been printing out parts for a good part of a month, and yeah, we're hoping to get that going.
I think it's really cool that you print parts for the other printers.
Yeah, self-replicating machines, self-replicating rapid prototyping machines, RepRap. It's cool stuff. It's like the first step to living in the Star Trek universe. And I'm a big fan of 3D printing and how democratizing it is.
Yeah, it is. Thank you, Jen.